Thank you very much. Can you all hear me okay? Great. Thank you for the introduction. I've never been introduced as Professor Moriarty. I'm not a professor, just so everyone is clear about that. Manage your expectations here. So I'm going to talk to you today about designing for artificial intelligence. And we've some ideas about how to approach that, some lessons I've learned with the team I work with, and we're going to look at where that's going and what that means. So, my name is John Moriarty. I'm a design lead with Fjord Dublin. I'm based in the Dock, which is Accenture's Centre for Innovation in Dublin, Ireland. And so Fjord, first of all, is a design agency. There's about 28 studios worldwide, about 1,000 designers. And the Dublin studio is part of, which was acquired by Accenture, I should mention, 5 years ago. And the Dublin studio is part of Accenture's Centre for Innovation, which is a global centre for excellence in artificial intelligence and emerging technologies. And we work with the design team of about 50 people, work alongside an equal-sized team of analytics and AI experts, software developers, and then we've got a number of domain experts across certain areas. And the mandate that we have is it's a research and development centre where we look at the overlap of human-centred design and emerging technologies. And we look ahead for ourselves and for Accenture and for our clients about what this means, and we help our clients chart that course. And one of the big questions that comes through the doc in general, and it's a big topic, one of the areas that we're focused on, is artificial intelligence. And we get a lot of clients coming into our doors who are curious about AI, they're concerned about what it means and what it means for their business. And they're also a little bit confused, because I think we can all relate to this, that AI is a very confusing term and a very confusing domain, and it's an umbrella term for a lot of different things, and depending on your background and your perspective and your experience, it can mean very different things to different people. So what that results in is often conversations like this. So you've got two prominent technologists, Mark Zuckerberg and Elon Musk, arguing on Twitter about, first of all, what AI is, and also where it's headed, whether it's a force for good or not. So, you've got two of the most prominent technologists today who don't necessarily see eye to eye about what AI is, it's not surprising. And to start to understand what AI is, first of all, we're going to just go back to some first principles. We're going to look at some examples of where it is today, and then we're going to look at some frameworks that we use as a design team to unpack this and to understand what it might mean for clients. So today, when we look at we've got the real world, and we've got machine systems that interact with our world at its most elemental. And then we've got structured information, typically, within this real world that is fed into a number of sensors. So these sensors could be microphones in your Amazon Echo, that could be the camera on your smartphone, it could be any number of sensors, any sensing technology that takes in real-world information into a machine interface. And then generally that's processed and evaluated against a set of rules, and there's actions that are performed against that. And those actions result in automated tasks. And so I hear you ask, is that not just automation? And you're absolutely correct. So a lot of our clients come in and say, we need AI, we need to do this, this, and this, and the question back is often, well, it sounds like you just need to automate some tasks, and it sounds like that's not necessarily AI, and so we spend a lot of time unpacking what that actually means. So just to understand, I suppose, at a very basic level, what AI might look like in comparison to that model. So you got the same overall structure, but the big difference here, what an AI system can enable, is the ability to not just take in structured data. So by structured, we mean it could be a spreadsheet, or it could be a labeled set of photos, or it could be information that the computer or the machine knows what it's looking at. But with AI, you have the ability to take in unstructured information and make sense of that. So that could be a noise file, or a sound file, or it could be a set of images that this system has not seen before. And it's using its own knowledge that has been learned over time to understand what that might mean. So you've got structured and unstructured data. So the ability to take in unstructured data is a key differentiation. That goes into the same sensing technologies, and the same comprehension is applied. So you've got the algorithm that essentially decides what to do with that. And then there's actions performed that result in the AI applications that we're familiar with today. But the key differentiation here is that there's a loop that it's involved. So this is, the term machine learning. So there's a learning process that happens where this learning process and all these different stages in this loop are fed back in each time, and this system gets smarter and smarter over time. So at its most basic, that's a core distinction between automated and AI systems. And even when we go back to another level again, if we look at the Webster dictionary definition of what AI is, so they describe it as the capability of a machine to imitate intelligent human behavior. So it sounds pretty simple, right? That's a nice, simple, succinct definition, but when you start to look at what does imitating intelligent human behavior really mean? What is human behavior? What does intelligence even mean? Intelligence can mean different things, depending on the context. So we'll look at a few examples of how AI is applied in our lives today to help us understand where things are right now. So one of the most common examples we are all familiar with is the ability of AI systems like Facebook uses or Google to categorize our photos. They find our friends, they group them together and say, hey, we think this is someone of interest. And it helps you find information and navigate that. You've also got Waymo, Google's or Alphabet's self-driving car arm, who are using artificial intelligence to make sense of the world around it. So make sense of the complex, messy world. They're categorizing information, and they're not just categorizing, but they're predicting what these objects in the real world are going to do. But most of us probably just use this to get recommendations on our Netflix or Spotify, right? So that's one of the common use cases that we are all familiar with. And what this in particular shows us, and the Facebook example show us, is that you can question if that's imitating human behavior, but I question if that is really intelligent, if that's really our definition and our understanding of what real intelligence is. It's smart, and it's classifying things and processing them, but does it stand up against our idea of what AI really is? I think it's questionable. And this quote by John McCarthy, he's one of the founders of AI. Essentially, he coined the term back in the 50s, and I think it's really apt. So as soon as it works, no one calls it AI anymore. So this idea that the examples we're familiar with today are so deeply embedded into our lives that we don't even see them anymore. It's just part of the experience, and we just roll it in. We don't necessarily say, oh, there's the AI at work. We just see it as part of the overall user experience. And so when it works well, you're not aware of it. And that's where it's working at its best. But what's really interesting is that, of course, AI is not a static thing. It's not a static idea or a set of technologies. It's constantly evolving. And our understanding of these technologies and how we can leverage them and apply them into our world is constantly evolving. And this is a great example from Autodesk, which as designers, I think we will really appreciate. They created a product called Dreamcatcher a few years ago, so I'll play the video. Give you a little sense of it. Is there sound?
Design without drawing, all of which...
I'll just play it again.
What if you could come up with thousands of options for a single design without drawing, all of which meet specific goals set by the designer? And from those options, pick the one design that delivers on the most important criteria, the design you couldn't possibly have imagined.
So what's happening here is Autodesk have created this constraints-based program that the designer sets the set of parameters for what they want to get as an output. So in this case, they're designing a drone that needs to get a certain payload, a certain volume, and a certain weight to be able to fly against a certain set of criteria. They want a certain degree of rigidity and robustness with this. And then the options for what that would entail are generated automatically. And they've set one of the constraints to be that it can use additive manufacturing, so 3D printing in this case, as a manufacturing process. So that opens up this whole new opportunity space. So from a design point of view, it's essentially another tool, right? It's another way that we can ideate, but it blows up the opportunity space for us to explore. And you could question, is that imitating intelligent human behavior? And I think that is. I think that's getting really close to what we as designers do. We set out our constraints, we sketch some options, and we evaluate those options against what we think is going to be successful. And what's really interesting here is it's not a replacement to a process as such. It's augmenting and amplifying the human process. So it's enabling us to go further than we possibly could with our current skill set, or certainly within the time that we would have spent doing that. You might get to all these options eventually, but it might take you a lifetime. There's also other examples, such as Google's Deep Dream, which are also examples of less constrained behavior. And in this case, this is a computer vision system that's looking at the world, and it's not looking to detect objects, but rather it's looking to project objects into it. So this is what this system has been trained upon only a small set of objects, in this case, animals. You can see feature very prominently in a kind of slightly trippy way. And so this system is trying to make sense of the real world around it, only knowing what it's been trained upon. So it only knows these images, and therefore it looks at the world, and all it sees is cats and dogs' eyes and faces, and it's trying to put them together. So you end up with these very strange examples. And is that imitating intelligent human behavior? I think it depends on what you're taking, but maybe. So things get really interesting and slightly unsettling when you take these technologies and you apply them to a web scale. So you've got the fake news crisis, for example. That's something we're all familiar with. So where these technologies, suddenly you plug them into platforms like Facebook, Google, and they explode. So they're suddenly used by millions or even billions of people without having been fully tested and verified what the actual consequences, either unintended or intended, may be. And you've got examples such as the judicial sentencing in the US, where there was racial bias embedded within those AI algorithms that were being used to determine sentencing for individuals. You've also got Amazon, who recently had to pull a recruitment tool, AI-powered recruitment tool, that had a deep gender bias based into it. And that was based on its own data, so it wasn't the fault as such of the algorithm. The algorithm was just a tool that was doing a job. But it was the data set that was feeding that algorithm hadn't been verified and hadn't been put through due process to understand if there was any bias within that. There's also examples of that are appearing of what are called deep fakes, such as this one.
How about this? Simply,
get some audio.
President Trump is a total and complete dipshit. Now, you see, I would never say these things, at least not in a public address, but someone else would. Someone like Jordan Peele. This is a dangerous time. Moving forward, we need to be more vigilant with what we trust from the internet.
So this example is, this actor on the right is an impersonator, so that's actually his voice. And what's happening here is they've got a camera trained on him that has been superimposed and recreating this footage of Obama. So the machine learning system has been trained on multiple hours of footage of Obama and has been able to determine that these vowels and this noise, these sounds, translate into this kind of movement and facial movement and expressions. They're called GANs. Really interesting, really fascinating, but also very scary, right? And DARPA has been looking into this, the US Defense Agency, and they've just recently admitted that it may be a losing battle, or most likely is a losing battle, in order to detect these. So they're getting to the point where they're so accurate that we no longer know if video footage of politicians saying things are real, and verifying these sources is getting incredibly difficult. So you can obviously understand the implications of that. So is this imitating intelligent human behavior? I think it's certainly aspects of human behavior, but it shows you some of the darker sides of where technology can go. So it's just a tool, but it can be used for good and for bad. And this gets to the point which Kevin Kelly puts very well. So we're morphing so fast that our ability to invent new things outpaces the rate that we can civilize them. So the ability to create new things and the ability to progress our technology is just the tools and the modes of access are just decreasing all the time. But we aren't giving these the time to settle and to understand what they might mean. The rate of acceleration of innovation and technological innovation is just changing all the time, and it's ramping up all the time. And we need to figure out better ways at how we can harness these for good, but also understand the unintended consequences so that we don't fall into the traps that just happened. And so when we look at why this is happening, why are we in this space where we're quite confused? Why are we in this space where clients are coming in the door saying, we need AI, we need one of those AI things, please? There's this AI FOMO that's out there, right? Everybody wants a slice of this pie. Everybody's hearing about AI. They all say this is a new big thing. They're hearing it from every angle. They don't necessarily know what it is, but they're pretty sure they want a part of it. And they want a slice of the money that might be associated with it, because, of course, you see the hockey stick curve to one of the previous presentations where this is going to grow, and if you're not on the bandwagon, you're going to miss the boat, and everyone else is going to get there instead of you. And Apple and Google, Facebook, they're acquiring startups like hotcakes, and they're extracting the data from these startups to create new, interesting services. But there's also clients who are just struggling to figure out what this even means, let alone how they can get value from this technologies or these technologies. And then there's another reason, which is the media hype, of course. So the media is just saturating these. Every week, every day, there's stories like these that are, the robot takeover is on the way. AI is going to take all our jobs. And the point here is that it's typically very polarized. It's typically quite black and white, and it's very absolute. Whereas, of course, we know that's not the reality. That doesn't reflect how we all see this day to day. So the media likes to play this very amplified view of the world, which isn't very helpful. So that gets to the point about how should we think about AI, and this is something we've been spending a lot of time thinking about in Fjord and in the doc. And we've developed a set of tools and a set of frameworks to help us interpret what we can do, how we can have smart, intelligent conversations with our clients that enable us to have to move forward and to create value and to understand what the real applications may be and whether we can match up those human needs with the actual technological applications. So one of the things we've done is, before I get to that, one of the reasons that we need to do that is because when you look at artificial intelligence, it is an umbrella term. It is an umbrella term for a lot of different technologies. And most of the conversations that exist around AI today come from a technological perspective. So you might hear about things like machine learning, graph analysis, supervised learning, natural language processing. These are all valid terms. They're all very interesting. They're all very accurate, but they're all very unrelatable. As designers and as humans, they don't necessarily mean much to us, right? We don't necessarily know where to start with these. And so it's not very helpful to start with these terms as a conversation because it doesn't tell us what we can do with them. So what we've done is we've taken these terms and we've applied a human lens to these terms. And we've got this framework here. So instead of talking about computer vision, we talk about the ability to see, just simplifying it right down to a human level, to something we can relate to. Instead of natural language processing, we talk about the ability to read. And we've got hearing and touch and recommending and creating. So these are all actions that as designers and people we can all immediately relate to and immediately start to grasp. And once we approach the technology from this lens, it helps us to understand the applications and it helps our clients understand what they may mean. So if we dive into some of these in detail. So starting with computer vision, this is an example from some of our colleagues in Fjord Austin who worked with Whole Foods to create an in-store experience that looks at wayfinding and product recommendations. So really useful, it's in your pocket, you get these recommendations, you get this added value. There's also the ability to see the imperceptible. So this is an example from MIT, some research that was just recently released, where they are taking standard webcam footage and they're processing that footage and amplifying the signals to search for certain things. So in this case, this footage is trained on this baby who's barely breathing. You can see there's some very, very subtle movement there. But it's not very perceptible. But if we take that signal and we amplify that against a certain set of constraints, we can actually see this in a very overt way. And we're doing the same thing for the actual coloring as well. So in this case, we can actually see the pulse. And so this gives us a pulse reading using standard imaging technology that gets up to the same level of accuracy as clinical systems. So you can imagine the implications for health devices and services are quite profound from this point of view, and the accessibility of these too. When we talk about reading, it's something, as designers, we like to understand sentiments of people, we like to, build empathy with people, but doing that at scale, what happens when we need to understand the sentiments of millions of people at the same time? That's obviously very challenging. So we look at natural language processing as a way to interpret the world. And this is an example of a project from the doc, where we examined social media to identify, first of all, patterns of interest and groups of interest. So in the case, we were looking at subgroups that exist within social media who use coded language, such as white supremacist groups or different kind of groups that don't necessarily want to be found, they don't want to be identified, but they want to have a conversation among themselves. So they have this coded language, they use visual memes, they use different techniques to refer to the subjects they're talking about, and they're very difficult to detect. So what we did was we analyzed millions of tweets. We then were able to recognize, okay, we think this conversation is something of interest against the criteria that we've said, and then we analyzed the actual language within that, and we were able to infer, using the way the language is discussed and the way these objects and words are used, we were able to infer some meaning from that. So we can then identify, okay, this is a white supremacist group. They're talking about a very racist topic here, for example, and we can then, that social media platform can take action. We've also got the ability to hear at scale, which offers new opportunities. So when we can listen to multiple signals simultaneously, or we can take in a very large volume of audio signals, we can do really interesting things. Here's an example from Google that illustrates this point.
This is an experiment we made that uses machine learning to organize thousands of bird sounds into an interactive visualization.
Bird sounds can be really difficult to learn because there's so many species out there, and some of them sound really similar. And at times you might just need to be distinguishing between a note that slurs up or a note that, drops in pitch. And these can be really, really subtle differences.
So really interesting, and this particular example, you can imagine how it could be really useful for remote wildlife studies, for tracking populations of animals. But it's also this same technique, this ability to take in audio and synthesize that and group that and identify the patterns and break it down has multiple applications. So for example, it's used by industrial companies, utilities and so on, to identify gas leaks. So they're listening for sounds in pipes to identify a signal that corresponds to a gas leak. It's also used by Formula 1 teams to reverse engineer gearing strategies of competitors just by listening to the sound of the car going around the track. And we've also got touch. So when we talk about touch, we really mean robotics. And robotics is, of course, not a new term, and robotics is not AI, but AI is changing robotics. And what it enables is the ability for a much more collaborative approach with robotics. So when we embed things like computer vision and sensing equipment into these systems, it enables us to break down the barriers that currently exist with working with these robots. So in this case, this lady is training this robot, so in a much more natural way. Instead of having to program the XYZ coordinates, you can just move this around and direct it to do the things it wants, and then it can replicate that. And then you can actually work alongside that. And if you walk into the path of that robot, it will stop before it crushes you, whereas currently these machines are typically in cages and they're off bounds for any human collaboration. And recommending is something, of course, we can all relate to, and it's one of the key aspects of AI that we can understand, I suppose. And one of the projects in the doc that we're using this, aside from the common Spotify, Netflix examples, of course, one of the examples we're doing in the doc is around demand forecasting and route optimization to recommend optimum strategies for postal and courier providers to plan their resources, so to plan their routes and their drivers and their vans, to put the resources at the right place at the right time. And it's offering the likes of postal providers new ways to work and to stay competitive in a very competitive industry. And then you've also got creation. So we saw the example of Autodesk's Dreamcatcher program, but there's also other examples of what are called computational creativity, which is a sector of AI that has really exploded in the last year. So this example here by Microsoft Research is an example of this bird on the bottom right doesn't exist in the real world. This was based on a request, a very simple request, to create a yellow and black bird with a short beak. And then from that request, it was able to look at the database that it had been fed, the training model it had been fed upon, which was millions of images of birds, and was able to recreate this, what it believed is a realistic example of a bird. Now, we put it on a floating branch, so it didn't necessarily have the full context, but it's pretty compelling as very believable as an end result. And even and this has applications in terms of product generation and product innovation. When you look at these handbags here, for example, the shoes on the bottom don't exist. They were based on the request to create a shoe that looks like this handbag. So really, really interesting example. So this provides us, hopefully this framework is something that that you can relate to, and we find it really useful, and we find it really a really beneficial way to talk about this. I'll just talk quickly about where we're going next. And what these examples we showed here was that we're really kind of trying to take the conversation beyond automation. What they show is that it's when the human and the machine collaborate together is that we achieve the best results. And I'll just go through a very quick example of a final project in the doc that looks at this. So we worked with one of the large social media companies. They came to us with a challenge, which was that currently they employ thousands of content moderators. And this is a really terrible job. So these are people, when there's unsuitable content is flagged on one of the social media platforms as being problematic for whatever reason, people have to review that. And the content these people need to review and need to see can often be quite distressing and quite horrific. And it came to us as an automation challenge, but but one of the challenges, aside from just the ability to make sense of this, and can we kind of automate this and make it a simpler process and a nicer process for these employees, there's also the sheer volume of video that was being uploaded. So 400 hours per minute means you can never work proactively in that way with a purely human workforce. You need to work reactively. So you need to rely on people to flag this content, and then it gets pulled down reactively. So there's content that can sit up there for a long time before it's actually flagged. That could be quite problematic. So what we did was so this is just an example of how the process works today. So human moderators flag content, and then or content is flagged, and then they decide if it's to be pulled or not against a set of policies. So we looked at an AI system to do the same thing. And what we were able to do, what we found was that the AI system was pretty good, but it wasn't perfect. There were still lots of grey areas, and this is because partly due to the technological limitations of the AI systems, they're not perfect, and also the actual content policies are often very, very blurred. So when you look across regions and different cultural differences, one thing that might be a parody in one location might be deeply offensive in another location. So a lot of these were still referred to humans. So what we did was we flipped this, and we said, okay, well, what if we use this as a way to flag content in advance? And what that let us do is to pull the really obvious cases. So it let us say, okay, well, we know these are definitely against the policy, these are definitely for it. And then, I won't go through this, this is an example of the UI, but what we did was we identified just the relevant keyframes to limit the amount of exposure that these moderators had to sit through. But what this ultimately enabled, by bringing the humans and the AI together, enabled them to work as a living system, and enabled us to work at a much larger scale and catch a much larger scale of content than was previously possible. So both the machine on its own couldn't have done this, and the humans on their own couldn't have done this. They required both each other to collaborate to achieve this to work and to get this living system to be effective. And this takes us towards the next point, which is about collaboration. So what does collaboration look like? And we can infer some examples from the past. So when Garry Kasparov was beaten by IBM's Deep Blue AI program, it kicked off this new wave of chess called Centaur chess, which is about where chess players were using machines as an aid to their play. So there was two players, both with access to these deep learning computers, that were playing against each other, and it actually changed the style of chess and changed the way chess is played. And what it introduced was new strategies for gameplay and improved performance. And when you flip this to a business context, what are the new strategies that we can infer from AI? What are the new ways that we can work? And there's some great examples. Like Harvard had an example last year where there was an AI that was built to detect cancerous cells, pathology AI, and on its own it was about 96% accurate. Working with the human on their own was, the AI on its own was 96% accurate. The human was 98.5% accurate, but working together they got to an accuracy of 99.5%. So really, really impactful. And this is the final point. I'm really out of time, or I'm out of time. So very quickly, this is about symbiosis. So what does that look like? When we look to design AI system into our systems and into our services and experience, we like to think about the AI as a teammate. And when we think about that, what are the qualities of a great teammate that you want to reflect in a system? So we talk about, we like efficiency, communication, adaptability, self-improvement, spontaneity, and expertise. These are all qualities we all admire in our colleagues. And so when we flip that to what does that mean for a teammate, for an AI teammate, communication becomes observability. So these are principles that we use. So we want to be able to see what is happening. We want to be able to expose the processes so we can understand the actions that are taken. And we need to be able to direct those actions if needed. And we need to be able to give feedback into that system if needed. And there needs to be resilience. So there needs to be multiple layers. If one thing fails, what happened next? We need to consider that. When we talk about efficiency, it needs to be responsive. It needs to react in a time that is reasonable. And then finally, we talk about spontaneity. That means creativity. We want these AI systems to introduce us to new ways of working, to not just automate what we do already, but to provide new lenses and new ways of working. So to close with Kevin Kelly, it's not a race against the machines, but this is a race with the machines. And that's our perspective, and that's what we really believe is going to be the future, and that's what we as designers are really focusing on. It's about collaborating with AI and understanding that, and having these frameworks that will enable the conversation to move to a meaningful point, away from the scaremongering and into something where we can actually generate value for clients. Thanks very much.